All right, now that you have listened to the plate tectonics wrap and you have watched the introduction video on plate tectonics and continental drift, you've got a little bit of knowledge about these plate boundaries. It's time to dig deeper. We're going to take some notes and go through some examples together in this video, and then there's going to be some activities for you to do in your notebook, which you will self-check. Self-check means that the answers will be on the slide after the directions, and once you have completed it, you will check it on your own. If you have questions or you miss something, you don't understand why, you need to make sure that you ask. But before we get to that, let's get started with our notes. So turn to this page in your purple packet. It should be right after the plate tectonics wrap. It says plate boundaries at the top, and you can see we're going to be talking about the type of boundary. We're going to sketch the boundaries, just a quick sketch, nothing fancy. We'll talk about the movement and what forms, the features that happen at that boundary, and we'll come up with some examples of those features. We'll talk about divergent boundaries, transform boundaries, convergent boundaries, and convergent subduction boundaries, of which there are two different types. So let's get started with divergent. I'm going to change my screen, but you will still fill in the sketch, the movement, the description, and the examples. So here we go. The first one up is divergent. So at a divergent boundary, you can see the plates divide. They go apart. You heard that in the song. You heard it in the video. So we're talking about plates dividing at a divergent boundary. So in the box that says sketch a boundary for divergent, you're going to draw two arrows, and they're going to be pointing away from each other. Divergent, divide. You need to remember that. Divergent, divide. We're going to write that. Divergent, divide. We're going to write divide. That's our movement. Remember, divide means move away from each other. They move apart. Divergent, divide. That was the second box in that row. The next box says description or features of the plate boundary. The features are the formations, the things that form there. There's three for this one. We can have seafloor spreading, you learned a little bit about seafloor spreading in the Explore It station of your lab. Seafloor spreading was when, at a divergent boundary, the magma bubbles up from underneath the earth. Magma bubbles up, and then it cools. And as it cools, it creates new crust. And then that splits apart more because it's at a divergent boundary. And more new magma comes up and cools and creates crust. So at seafloor spreading, we find the newer crust towards the center, right at that boundary. And the farther you get away from that boundary, the older the crust gets. So we have seafloor spreading. We can also have mid-ocean ridges. Mid-ocean ridges are sort of like underwater mountain ranges. It's where underneath the ground it ends up being kind of spiky like this, and that is because the magma will come up and it'll create new crust, and then it'll spread apart. It'll come up, it'll create new crust, and it'll spread apart. And as it does that and it's spreading apart, we end up with these little ridges, these little bumps, because we have the new crust towards the middle, and then we have older crust out on the edge. So we have these little ridges, these little bumps, kind of like mini mountains underwater. And then we can also have rift valleys. Rift valleys are valleys. And you know from social studies that a valley is shaped like the letter V. Valleys. It kind of dips down. This would be where it divides. This is that boundary line right through here. And again, it'll come up and then it'll split. And all these things together happen at a divergent boundary. And an example of that for your last column would be the Mid-Atlantic Ridge. The Mid-Atlantic Ridge is a mid-ocean ridge that's found in the middle of the Atlantic Ocean. That's why it's called the Mid-Atlantic Ridge. And that's divergent boundaries. The next one on your paper is transform plate boundaries. Transform plate boundaries, as you can see in here and as you learned in the video, transform tectonic plates slide. That was when your hands slid past each other. Transform tectonic plates slide. So our sketch for this one is a lot like our picture here. You can see arrows are going opposite directions, but instead of pointing away from each other, they're kind of going next to each other a little bit before they go away. So we have one going this way, one sliding this way. So transform tectonic plates slide is our movement. They slide by each other. Before we go on, I want you to take your hands and make two fists. And put your hands together, rub your knuckles against each other. As you do that, I want you to feel what happens. You should kind of feel your knuckles bumping over each other. Your hands might be vibrating or shaking a little bit. Do you know what we call it when the earth shakes a little bit like that? It's called an earthquake. And that's exactly what happens at transform boundaries. Transform boundaries are where the fault lines meet and slide past each other. So we have fault lines. The fault lines are the lines between the plates. Fault lines. And as those fault lines rub or slide against each other at a transform boundary, just like your knuckles rubbing and sliding past each other, the Earth's going to start to shake, and we call that an earthquake. And that's the other big feature here. An example of that is the really famous one in California. They made a movie about it, the San Andreas Fault. Some of you may have seen that movie, some of you maybe not. The San Andreas Fault is a transform boundary that runs right along California, and that's the major reason that California has so many earthquakes is because of that transform boundary, that fault line that's right there. So far we did divergent divide and transform slide. The next one on your note sheet is convergent. Convergent plate boundaries like to collide. As you can see in this picture, the arrows are going towards each other. So our quick sketch here, we're going to have two arrows, and they're going to be pointing towards each other, straight towards each other. Convergent collide, just like in the song. That's our movement. And as they collide, they come together, and when they push hard enough against each other, they start to do this. They start to uplift. They lift up a little bit, and they create these. They create mountain ranges because of that uplift. So the formations here are mountains. It'd be like taking your hands, lay your hands out flat, and then push your fingers towards each other. As you do that, if you go slowly, they start to raise up. They make a little mountain peak. That's what happens at a convergent boundary. The plates collide, they uplift, they push against each other, and they make mountains. One of the most famous examples is the Himalayan mountains. Himalaya mountains. Oops, I forgot an A. Hang on, let me erase that. Spell it correctly for you. Himalaya, Himalaya Mountains. So now we've done convergent collide, divergent divide, transform tectonic plate slide. Those are all the ones that were in the wrap. But there are actually a couple more that you will need to know for formative assessment number 1. These ones are really important, and they make some different kinds of things. These are called subduction boundaries, okay, or convergent subduction, but we can just call them subduction boundaries. And the word subduction means that one goes under the other. Subduct means one goes under. That goes for both types of subduction boundaries. The first one in your chart is ocean, ocean, or we can say oceanic, oceanic. This is where two pieces of oceanic crust converge. They come together. And when that happens, one is going to go under the other. So here's how we're going to draw it. I showed you the motion for subduction a while ago. So we have one arrow is going to go straight. The other arrow is going to curve and go under it. So when we're dealing with ocean and ocean, two oceanic crusts, the older crust so we'll label this one older. The older crust will go under the newer crust. So here, in our picture up here, you can see this is the older. The older crust is subducting below the newer crust. And that is because the older crust, remember, the magma comes up and it cools, and it comes up and it cools, and it comes up and it cools. And as it does that, it adds layer upon layer upon layer upon layer. So the older the crust is, the more layer it has, and the more dense it is, the heavier it is, and the heavier things like to sink. So the older crust will sink below the newer crust. So we write, for our movement, we write older subducts, or goes under, under the newer one. The older crust subducts under the newer one because it's more dense, it's heavier. And this forms, you can see in this picture right here, a volcano underwater. Forms underwater volcanoes. And as those underwater volcanoes erupt, the magma hits the water and it starts to cool. And as it cools, it forms these things that float in the middle of the ocean and are surrounded by water on all sides. We call them islands or island chains. And a really famous island chain that we're really familiar with is Hawaii. That was formed by underwater volcanoes. That was one type of subduction. Oceanic and oceanic, two oceanic crusts. The older one will always go under the newer one. The last boundary in your chart is also a subduction boundary. Remember, subduction means that one is going under the other one. But this one says ocean continent or oceanic continental. Here we have two different types of crust meeting, not the same. So our picture, the arrows will be doing the same thing. One will go straight and one will curve down underneath it. But when I label them, I'm going to label them differently. In this case, the continental crust, you need to write out the word, not just put a C. Will go over the oceanic crust. Okay, you can see it up in this picture. The oceanic crust is going to sink below the continental crust, which will go straight. The oceanic subducts under the continental because it is more dense. Okay, so when we're talking about the movement, we say that. We say oceanic, the oceanic crust, subducts under the continental crust. The oceanic subducts under the continental. The oceanic will sink, the continental will go over the top of it. And when that happens, as you can see right here, it's going to break into the asthenosphere. It's going to break down into this magma here, and that magma is going to come up out of like the little mountains that it created. We don't call them mountains when they erupt magma. We call them volcanoes. So this will form a volcano. And an example you might have heard of is Mount St. Helens. It was formed in that way. And that's all the boundaries we've got. There are 5 types of boundaries that you will need to know for formative assessment number 1. This sheet that you just filled in will be a great study tool for formative assessment number 1 because formative number 1 will ask you to sketch the boundaries, so draw out these arrows, label them if necessary, talk about the motion that happens, so convergent collides, divergent divides, which one subducts under the other one, and it's also going to ask you what forms there, so these features or formations. The only thing you won't need to know is an example of each, but you will need to know all 5 of these boundaries: convergent, divergent, transform, oceanic subduction, and oceanic continental subduction. You will need to know all 5 of them for formative number 1. So to help get you ready, the next thing you're going to do is some activities in your science notebook. So go ahead and go to the next slide on blend space, look for the directions, follow them, complete the activity, and self-check. If you have questions, be sure to ask. Good luck.